Okay, well, assalamu alaikum and good morning once again, right? So we've been talking about network programming, the concept of it, and we have chosen the client-server model, right? We have seen in previous class how to create applications that are stream-based, okay, applications. Means the kind of communication is stream-based communication. That's basically what refers to TCP, okay, and for the kind of communication that we are relying on. And we have done that with sockets. We have a client side and we have a server side for which we wrote two different applications. But the two different applications, the logic of them corresponds to the logic of the service itself, right? Two parts of the service, one at the client, one at the server. The application that we have shown you was the simplest, or one of the simplest. It's basically an eco server or an eco service, right? And I'm not sure whether we already kind of executed the code in front of you. We have explained the code, right? Did I execute there and show you how does it work? Okay, good. So in fact, that code, okay, it works only with one client, and it doesn't work with multiple clients. Did we demonstrate that? No? Okay. So let me just prove to you that it only works for what? For one client at a time. So I'm going to run the server now. Okay. So this is our eco server running. Okay. Now I will run a client. Okay, and as we've seen before, we can actually here to choose, okay, the console for the client that we ran. And I think we wrote something like this, hi, and the server replied, hi, okay. We continue writing other things, okay, right? And the server continues to respond. Now, while this client is running, I'm going to run another client now, okay? So this is another client that I'm running. Okay, and if I want to switch to the console of it, basically I can just go here, okay, to switch to the console of this client. Now let me write like hi from client 2. The server is not responding, okay? Why? Because our service is single-threaded, okay? The server can only take care of one client at a time, right? Okay, so if you want to make this service multi-threaded, what do we need to do? We have to use a class that extends the thread or implements runnable, correct? Okay, so if I am to do that, I have to do it for the service or the server? The service. However, my service here, if you notice, okay, if I show you the server code, my service is just a method, right? Okay, eco service is a method. Is a method. How can I make a method to extend thread? Can I? I can't, right? So instead, the very first thing, okay, is to put this service logic, put it in a class, right? And this is what we're doing here in the second version of this, okay? The second version has only this modification. This is my server code in the second version. Okay, and what I'm doing here is simply moving the code of the service method to a class, and the class name is ecoservice again. Okay, and in the server, instead if you call the method, you just create an object of the class which has the code of the service. Correct? In both cases, of course, we need to pass the socket object that represents the client for this connection. Right? Excellent. So what is the code of this class, the eco service? You can see the code of it here. It's a class, okay, right, that basically receives in its constructor the socket object representing the client, right? And it has a method called service, okay? Method called service. And if you notice here in the constructor, we're calling this method. We're calling the method. So in the server, we only create an object of this class, passing the socket object representing the client. And here the constructor will set this socket object to the client that it has defined locally and do what? Call the service. So what's the code of the service here? It's exactly the same code of the method that we used to have earlier, right? The service method, exactly the same code, no changes, okay? So now if I have the service implemented as a class, then to make this service multi-threaded, what do I need to do? I need to have this class extends thread, okay, or implements runnable, right? And if I am to extend the thread or implement runnable in this class, it means that this method should be what? What's the name of this method? Run, right? A class that extends thread or implements runnable should have the method run. And what should be inside the method run? The code, what should it be? This code, right? The code that I have now under the service method, correct? And do I have to call it? I don't have to call it, okay? When you create an object, okay, of a class that extends thread or implements runnable, okay, the method run will be called automatically, right? After the constructor is called, right? Because in the constructor here we do the setting. And this is the way to pass parameter or arguments to a thread, right? Through the constructor of a class that extends the thread or implements runnable. Do you understand how to change the service to be multi-threaded? Is it difficult? Okay. Now when I go back to the code that we had before, okay, so here still not responding, correct? Now if I go to client 1 that I have established earlier and I have thereby, okay, the service already disconnected. Now look at client 2. Now the server is responding to what? Client 2, okay? Okay, so we're gonna have bind here, okay, and let's just close all of these, including the server, okay? And now let's execute what? A multi-threaded service. So first, let me show you the code of it, okay? Which is exactly, the changes, very simple. So if you have a single-threaded service, what do you need to do? Put it in a class, okay? Make the class extends thread or implements runnable. The code of the service, the logic, put it inside the method run, right? And in the server, what do? You create an object of this and start it. An object of the class that has the service, which is a threaded class, and I start it, correct? Yes? Okay. Any question up to this point? Okay, so now let's see the code of the service. It's exactly the same code of what you've seen just now with the changes that we mentioned. Extends thread, right? I'm not calling here any method in the constructor because I already have a run method which has the same code of what we used to have there for the service, and it will be called automatically. Do we know how to change single threaded to multi-threaded? Now if I run this, okay, let me go for one client to run now, which is this client. Okay. Okay, so now this is a client running. Okay, say hi from client 1, server is responding. Okay, let me run another client while the first one is still running. Okay, run. Okay, now this is the other client. Okay, okay, hi from client 2, and still what? Responding. If you run even other clients as well, we'll keep responding and so on. Okay? If you go to client 1, okay, again, the server will respond and so on. Okay, so we're done here with multi-threaded, okay, okay, because I terminated the server, okay, before the clients, and that was the kind of exception that we get, okay. Next is to demonstrate to you another application protocol. Okay, so we have seen what, how to change a single-threaded server to a multi-threaded server in very simple steps. Of course, so far the classes that we have been using, the server socket, which has an API, Java API, you need to look at it. Okay, this is in java.net package. Okay, so I have choosing some of the methods and constructors for the classes server socket and socket, as well as one class which is the init address. Init address. If you see here from the class socket, for example, one of the methods of it is get init address. Get init address. This is called to create an init or to return an init address out of the socket object, right? It's a method of the class socket. So this init address, once you have it, what is it used for? Okay, so the init address here has many useful methods, such as get host address, which returns the IP address of the client who's connecting to the server, because the server already has a socket object representing the client, right? So the server can know the IP address of the client connecting. In fact, the server also can know the port number used at the client side to connect to the server, which is get what? The port, okay? And some other information as well, okay? So it's useful, okay, class that we can get information about the client about it. Of course, there are some other methods there, for example, to set performance preferences, okay? This is for the socket object, which means the server can set certain preferences for the connection with one particular client, and that includes what? Okay, the connection timeout, the latency, okay, the bandwidth to be assigned to a particular client, which means we can implement what? We can implement actually different service classes for the clients who are connecting to the server, correct? And we can give each one of them different what? Preferences, okay, for the connection, right? Okay, so there is much more actually that we can do also with network programming. So multi-threaded server, this is the concept of it. What you have is multiple clients connecting to the same server, and the server needs to service all of them simultaneously, okay? If you notice here, we have these two lines to represent what? That each client, okay, has its own input-output stream with the server, okay? Because these streams are, when we create them from the socket object, which represents the client, right? And every client has a socket object that represents it, okay? Good. So this is how we did that, actually, service, okay? Pass the client to it, and then start the service. That's what you need to do at the server, okay? The changing of the code, we have seen it just now. Now, the second thing is to look at another application protocol, which is basically the DNS service. DNS service. However, DNS service is much more complicated than an example to be presented to students in a class, right? So we can look at what? At one level DNS service. You know, DNS service is hierarchical, right? Does anyone know what's a DNS service? Domain name service? You know it, right? So basically, it has two operations. It has a lookup operation and a reverse lookup operation. In a lookup operation, you pass to the server a domain name, and the server will reply back IP address, one or more, right? Okay, so that's the normal lookup. However, there is a reverse lookup in which you pass what? The IP address, and you get back what? The domain name. How many domain names? One, in this case, one, right? But if you pass the domain name, you need to expect one or more, or a message saying cannot be resolved, correct? So, and of course, if the server that you are connecting to, the DNS server that offers this service, that you are connecting to, if it doesn't have information about the domain name you are requesting the IP address for, then what will this server do? It will forward your request to another DNS server, right? Which is basically upper in the hierarchy. It knows more, right? And if that one cannot, then it will forward to another one, and so, correct? Where we have, I'm not sure, 33 DNS servers all over the world, things like that, okay, distributed here and there, and some of them are replications. Not sure about the number. So what we're going to implement is one level. So one server, okay, and basically clients connected to it. if the domain name that you are asking for, okay, the server has no information about it, then you're going to get a message cannot resolve. We are not going to forward it to another server. But it would be a good exercise, okay, to do that, okay, to later on extend this, maybe in a project, okay, once you're given this code. Okay, good. So we already have a project idea. So to do so, to prepare this example, what I did is basically I used the NS lookup, okay, in Windows, okay, Microsoft Windows, and I have been writing there some domain names to get the IP addresses for. Okay, this is one example of what I wrote there. Google, for example, we have 2, 4, 5 IP addresses associated with the domain name google.com, right? So each time I got a result like that, I put it where? I put it in an array, okay? So this array has 2 columns. The very first column is what? Domain name. The second column, the associated IP address, okay? So you can see duplication in the first column sometimes, such as this for Google, okay? But you will not find it for what? The other way around, okay? Okay. Okay, so we have here, right? So I've created this array. Why? Because the lookup, what does it mean? Search, right? Search, okay? So we're gonna search this array. Of course, you can have it as a map, which is nicer, okay? But we can search this array, having either an entry here or an entry here, and we look for the corresponding one, okay? So if we have a domain name, we start searching, let's say linear search, okay? From the very first location of this array. Okay, we compare what we have as a domain name with the domain names here. When there is a match, we return this, right? We return the corresponding from the second column, okay? But we don't stop, we continue, because there might be another match, okay? Until finish. Now, while we're searching also, we set, at the very beginning, we set a variable which is found, Boolean variable. We set it to what? To false, because sometimes we might not find a match. So if there is any match, in our first match, we're gonna change that found to be what? True, okay? On the second match, you don't need to, I mean, it's already there, right? So when we go out of the search, okay, then we need to check whether found is true or false. Because if it's false, then what we're gonna return now a special string, right? Saying that what? The IP address, okay, cannot be, the domain name cannot be resolved to an IP address. As easy as that. So what am I doing here? We're modeling the solution. This is the logic of the solution, which is, again, the most important thing, not the code. Okay, code, a little bit, you can, I mean, help, reference, this and that, example from here, from there, you can put it together, you can have it working. But the logic of the solution is important. And here we're not talking about complicated logic, it's a very simple logic. Fine. So now we are not going to offer the DNS service as it is here. For example, here is command line, and you can do only what? The normal lookup. Okay? And as lookup, domain name, you expect IP addresses in this format. Command line. You don't know reverse lookup, right? So the one we are going to create, okay, will be something like this. The user will have an interface. Basically, the interface is this. This is at the client side. Client side, which means the client application, it will communicate with 2 things. The client application, the logic of the service. Okay? It will have a part that communicates with the user dealing with the client application, and another one, the client application communicates with the server, right? With the DNS server. Okay, good. So this is the menu to be displayed, options menu, 1, 2, 3, okay? And blocking for the user to enter an option. Based on the option, then we're gonna ask the user to enter additional arguments, okay, that are needed to be sent to the server. Okay? Right. So this is a simple interaction, okay, with the user. Now the service. When I look at when I have a specification of an application, a protocol, I have to decide the communication parties, okay, and the kind of communication that's local and that's network, okay, and so on. So for me, I just put this kind of sequence, okay, interaction, okay, a sequence of interaction. And I try to put there the general scenarios of interaction. So I say that this is the server side, okay? And this is the client side, okay, the logic of the application on the client side. This is the user who's interacting with the client, okay? At the very beginning, okay, we have to have the client application to connect to the server, correct? So that's the very first code in the client side. Connect to the server on a particular IP address and port number, which should be known, right? Because you are the one who are coding both sides. And then, now, give attention to the user. By what? By displaying a message, for example, on the screen with that menu that you have seen, which has the options 1, 2, 3, okay, for the user to choose from, okay? And then block. So most of these services, blocking services, right? Sequence, and there's blocking, waiting for, okay? Waiting for, okay? So here, you're gonna wait for the user to enter, okay? To enter what? An option. Once you get this option, send it to who? To the server. But do not expect anything back from the server. The server only good to know your option, that's all, okay? And now, get back to the client based on the option that had been entered, right? If it's exit, then that's a termination and we're done, okay? If it's 1, means normal lookup. So in this case, you have to display a message to the user asking the user to enter the domain name and block until the user enters what? The domain name, okay? Or reverse lookup, enter IP, and then you get that, read it from the user, and then send it to whom? To the server. Now, once you send it to the server will read it, okay, and then perform a particular process, which is the lookup process, and then return what? The result to the client. Return the result to the client. That result can be one single line, in the case of reverse lookup, right? Or multiple lines, correct? So, you have here to block waiting for the results from the service once you send what? The argument. Block, the client must block waiting for the what is received from the server. But do you know how many matching IP addresses? You don't know, right? So what we can do, we can get into a loop, okay? Keep reading, okay? Line by line from okay, a server where the server gonna send that, okay, we're gonna use the same, okay, writing line and reading line, of course, the corresponding at the client, until when? What is continuous loop? Until, let's say that no more results. So we have to represent something which means no more results. So let's that be, okay, a constant string, say end. Okay, so if the server sends end, means what? We're done. Okay, we're done. No more results. Okay, okay. And then each time you receive a result from the server, okay, you're gonna read it here, right, at the client, and display it to whom? To the user in a format that the user needs to see it in. Clear? So this kind of interaction logic and the blocking, waiting for, since this, wait for this, because this is what we are expecting. Okay, so this sequencing is important when you are to implement this kind of communication. So now let's maybe show you the code of this, okay, since we already have, okay. DNS, yes. Okay. This is, oh, sorry. This is the server. Server, the code of it, same code as other servers. Basically, create a server socket, and then go into an infinite loop if you want the server to be always offered, correct? In that infinite loop, accept connections. For each connection, return what? A socket representation of the client. And that's what we're getting, right? Server.accept the result that's returned from the accept method is saved in client, which is a socket object. Now, this client, we're going to send it to the service class. In fact, the service thread, right? So we have a new DNS service client. And then since this is a class that extends thread, we're going to have what? Dot start. That's all. It's the same code you see for the servers, all different servers. Now, what differs is what? The service, the code of the service. So now let's look at the logic of the service. This is what I told you about, okay, which is not really appropriate, okay, to have an array, okay, but we want to demonstrate logic, how we implement logic of things. We can have much better representations. So this is an array, okay, each entry in it, this is 2D array, is what? 2 columns. This is the first column, second column, first column, second column, and so, right? Okay, so I'm calling it DNS list. Okay, and of course we have the client that we're gonna receive it here through the constructor, and we will what? Assign it. Okay, so I'm assigning the client. In fact, also, whenever there is a connection, I can have a login. Okay, I can look to a file, okay, information about the client. But here I'm displaying it on the screen, the monitor of the server. Usually servers, they don't have monitors, right? It's just basically what's running and everything is fine. You don't interact with it, okay? Your interaction through maybe another computer, or you have special permission, okay, to log into that server and do some other stuff, okay? But we just demonstrating things. So what am I printing here? I'm displaying information about the client connecting. For example, I want to display what? The address, the IP address of the client connecting to the server. How can I do that? Okay, I have a socket object, which has a method, getInetAddress. This returns an inet address object, which is rich. It has a method which is what? getHostAddress. Okay? The same thing, it can also, we can also display the port number, okay, by getPort, but this one you can get it from the socket itself as well. Okay? And I can display the date to tell me the time, date, okay, of the connection and so on. We can do lots of things in there, but just to show you an example of one thing that you can do. Okay, fine. Now, let's go to the important thing in here. So this is DNS service, okay? And this is the run of it. The code is inside the run, right? So what do we do? The very first thing, for this kind of service, we have seen that the interaction is both ways, right? Which means we need to establish 2 streams, in and out stream, okay? Network streams. Now these streams, again, they are established using what? The socket object, the one we call it what? Client, right? So client get output stream, client get input stream, okay? Now the kind of input and output streams that we cascade to, the final ones, are what? A print writer and a buffered reader. They have very convenient methods to use. And I think we have seen that in a previous example, okay? This is the logic of the service, okay? Once the client connected to the server, okay, can do different NS lookups, right? Can keep interacting with the server until an exit is sent. So the server is supposed to keep listening as well. I mean, the service is supposed to keep providing the service as well, right? So here is the service code. We have while true, okay, while true. Of course, we check if the client always, we have to keep track of the client that is still alive. Okay, so we can do a code. This is precautions, okay, to have the client alive. If it's not alive, okay, if client equals none, means we're done already, so we go out of the while loop. We don't need to interact with the client. Now, there are options. There is an option that is first sent to the server, correct? That's what the client is sending to the server. So the very first thing that the server should do is to read what the client is sending. Right? So the logic of the server starts by reading what the client is sending. And what do we expect? An option, 1, 2, 3. Correct? But, you know, the user might send something else other than this. And for that, we have to do some kind of handling. Matalan, for example here, okay, what we read, okay, we check it whether it is an accepted, okay, option or not an accepted option. Now, as I mentioned before about the found, okay, we set found to be false. This is for the lookup because it's important for us. So we read the data, okay, from the client. That's why I call it what? C data. C data. And I already have the constant string int, okay, that will be sent after the lookup service, okay? After you return certain IP addresses, you send int, okay? Okay, C data is what I'm going to read from the client. We agreed it's the first interaction. So input dot read line, save it where? In C data, which is a string, okay? I could parse that to an integer, put it in an option, and do the switching based on it, okay? But I want to check whether it's correct or not. Now, this option, okay, which is 1, 2, 3 expected, okay, I want to check it. If option is not 3, okay, then what? We need to read additional data, right? Because if option is not 3, means 1, 2. That's what we are expecting, isn't it? 1, 2. And for 1, 2, this is either lookup or reverse lookup. And in the service, in this case, it's expecting either a domain name or IP address to be received from the client, correct? So the server here is going to block what? Reading. It says input.read line. That's the second line to be sent by the client. That's why, again, we save it in what? C data. We don't overwrite what's in C data because we already used it to put it in option, right? We put it in option. So this C data actually is the argument for either lookup or reverse lookup, which is either a domain name or an IP address. Depends on the option, correct? Now we can do the switching, okay, of the service. This is very common, okay, where we have sub-services, okay, to do switching there, okay, based on the option, based on the sub-service and how is it identified through numbers, through whatever certain formats, and so. So here I'm saying that if the option is 1, then this is what? A lookup service. Lookup service. And I already have the domain name that I want to look up, which is saved where? In C data, right? So what do? I go for linear search of the DNS list. Okay, so I'm starting from 0 until length, right? And I'm comparing what? I'm comparing the C data, which is the domain name. I'm comparing it with the entries in the first column. In the first column, which is column 0, right? So the column is fixed, column 0. I'm always in column 0, but I is changing, correct? Now, whenever there is a match, what do? I'm returning this match to the client, right? Return the match to the client. And what do? I change found to be true. Change it to be true. Now, when I finish that kind of lookup here at the server, okay, then I check. If not found, then what should I do? I should send a particular message to the client, and that is basically cannot resolve name to IP, okay? And that's basically sent to the network. To whom? To the client, right? Okay, using the output stream. After that, since I'm sending multiple services and we want a signal that no more results, okay, so what do I send? The special string end, which has in the content of it, if you see up there, the end capital letters, okay? So this will signal no more results. Easy, kind of logical things, isn't it? So this is logic. I mean, the actual new thing that you have is how to create a server, how to make it multi-threaded, how, right? These new classes that we have introduced. Okay. But we also need here to present to you the blocking logic and sequences, okay, how to create the sequence of the interaction as well. Now, if the option was 2, and that's case 2, then what do we need to do? Basically, you have an IP and you need to return what? The domain name. And in that case, there's one match. One match. So we get into a linear search for the DNS list, okay? And now we are searching the second column, which is column index 1, right? So that's why the column is fixed to 1. I is changing, the row is changing. And I already have C data. C data in this case represents the domain name or IP address. IP address, excellent. So when there is a match, if there is a match, then I'm gonna what? Send this message to the client, which is basically the formatted message with the domain name and the IP address. The client only need to display it as it is to the user, okay? And I also do the same thing for found, okay? So after the loop, I check. Look here, I don't, basically, when I found, I break, right? When there is a one match, break out, because there is only one match we are expecting. And then after the search, I check found. Okay, if not found, then send this, okay? And I'm not sending any special termination for the result. Why? Because if the client now is doing reverse lookup, then the client should have one read, right? One read, not multiple reads. So it doesn't need to know, okay, how many, okay, results it gets. It's only one result, so one read. And the third one, of course, is just handling, okay, if client, okay, so basically we need to do the exit in here, and this is the same exit code that you have seen before. Of course, if the option is something else, then we can do what? We can log it in the server. So here what I'm doing, I'm just displaying on the terminal of the server that unexpected option. But we can do some kind of login or another process to be followed, blah, 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 right? Clear? Yeah? Now let's see the logic of the client. Okay, the logic of the client, okay, connect to the server on this port, establish whatever streams needed, and again, okay, you can have this logic of service in a class. You call it again service, right? But this is the what? Client side of the service. And you can create an object of it here as well. Correct? I'm not doing that for the client, but you can, right? Actually, it's better to do it for the client that way. So I have options, okay, and I have data that comes from the keyboard, okay, and data that comes from where? The server, okay? And in this case, okay, I'm using like 3 streams, okay? 3 streams to communicate with 2 of them network streams and 1 with what? With the user. Of course, you can use a scanner object, right? You can have a scanner object and basically read from the user, okay, by next line, okay? But here, we are using buffer reader, okay, similar to the one that we're using for what? For the network. To tell you, actually, it's the same thing, streams, files locally or those, okay, streams with the network. The way we deal with them is the same. Okay, so we could have replaced that with what? Scanner object. Okay. Now, the logic is like this. Continuously interact. Okay, so while count is true, continue is true. Okay, because the signaling of it not true is by what? By having an option 3. Option 3 means you don't continue. Okay, terminate this. So we read from the user keyboard, we called it the buffered reader for the user, okay? Read line, okay, that's the data that we have. And basically, we get the option of it by parsing it to integer. And if it isn't what we are expecting, now you are client, right? So you have to handle your user errors, correct? Rather than send the error to the server. So basically, if what the user is entering is not an integer, okay, then what do we need to do? If it's not an integer, we will set that the option is 4. Set the option is 4, because in 4, we're going to redisplay the menu again and telling that you have entered, okay, some wrong value and so on. This is what we're doing in 4, okay? In 4, system.out.println, okay, wrong choice. Okay, and we go back to the loop, right? And going back to the loop here, okay, it will do what? It will print this, which is basically what? The option menu, right? The option menu. So it's one sentence. Clear? Okay. Now we have the option, okay? We switch on the option based on what the user entered. In case 1 means lookup service. And if it's a lookup service, then we have to communicate with the user to enter the domain, block for that. I have read line, block, until I get that data. And then the data I get, I send to whom? To the server. Output, this is the output network stream. Okay, I send it to whom? To the server, the data, which is in this case a domain name. right? And if you send the domain name to the server as a client, what should you do? You should expect what? Results coming from the server. So now you get into a while loop waiting for these results. How do I read the results? They are sent line by line, right? So I say input.read line, okay, and that's the server data, okay? As long as it's not this is special. And then what you get from the server, put it to the user, okay? Put it to the user. So basically system.out line as data. Keep doing so. Clear? Okay, and then after that, we break for the second option. Second case, basically, you get something from the user, and that is basically what? An IP address. An IP address that you write to the server. This is output, which is what? A network output stream. We write it to the server. And if I write this to the server, I expect the server to what? This is the option, right? This is the option, okay? So this is the option, the K data, and now I need to get the IP address from the user, okay? The user will be entering the IP address in K data here again, and I send it to whom? To the server, right? We already sent the option 2, and now this. And once I send this, I expect the server to send me only one result, which I can read here in one statement, input.read line, and that's the server data. Whatever it is, I will display it to the user and break, right? And on a third option, which is close, what do I do? Basically, just close the connection, close the socket, and so on. Clear? Yep. Okay, the sequencing is important, okay? Okay, otherwise you're going to have hanging kind of communication, hanging. You don't get results. Why? Because your sequence is not correct, the logic of the sequence. Let me maybe demonstrate this to you, okay? Let me run the server. So server is up waiting for connections on this particular port. Let us go for the client and we'll just run one client. Okay, so the client now we are interacting with is, okay. I switch console to the client, okay. So this is what the client got, okay. So let's choose option 1, okay. Now enter domain name. Let's say again google.com, okay. So now we get the IP addresses of it, and we got the menu again in case we want to do something else. So let's enter something else, okay. Yes. So let's choose okay 1, okay, and let's say www.only, which is wrong, right? So cannot resolve this IP address. Let's choose 2, okay, and in this case I have to enter IP address, okay. Let me just enter well a wrong 1, which is this is totally wrong, okay. Okay, 212.1, okay, which is not resolved. However, I can check one of them that already there, okay, and I can just enter that IP address. For example, let's have this one, okay, that corresponds to GM, okay, Control C. So now I choose what? 2, okay, and I will have that there, okay, and I get what? It is GM, and so, okay? And 3 exit, and you can run also multiple clients at the same time, and it will respond back nicely, okay? The last topic that we are left with, okay, is a self-study one. However, I'm going to cover it, okay? But, of course, not in today's class, we've done already. It is how to create, okay, network applications, okay, using what? Packet stream, rather than, bucket-based communication rather than stream-based communication. Bucket-based communication rather than stream-based communication, which means here UDP rather than TCP, okay? The concept is very easy, okay, and I have few slides there, okay? I tried to put it nicely to you, okay? Go through it. It's supposed to be self-study, additional, okay? Because it's out of your course syllabus. Anyway, what I explained even before was out of your syllabus. But remind me to go through it next week, okay? And the code is there as well. The code is in Blackboard. Try it, play with it.